So we have number 6 from homework 8. So looking at homework 8, number 6. So the first thing I need to do is determine what the vertex is. So I note that this is standard form. So to find the x-coordinate for the vertex, I can use the same formula that I'd use to find the axis of symmetry. That's negative b over 2a. So b is 4 and a is 1, so I get that the x-coordinate is negative 2. To find the y-coordinate, I'm just going to plug that in. Negative 2 squared is 4. 4 times negative 2 is negative 8. And plus 4 more gives me 0. So my vertex is the point negative 2, 0. So make my table. And then I'm going to pick 2 points to the left of the vertex. So I just need 2 x values that are less than negative 2. And then 2 values to the right of the vertex. So 2 values that are bigger than negative 2. Any 2 will do. I'm just going to pick the things that are easy to compute. So I don't want the numbers to get too far away from the vertex. And I'm going to try to aim for whole numbers just to make my life easier. But it doesn't really matter. To find the y-coordinates for those x's now, I'm just going to plug those values for x in. So negative 4 squared is 16. 4 times negative 4 is negative 16, plus 4 is 4. And we'll do plug negative 3 in. Negative 3 squared is 9. 4 times negative 3 is negative 12. Plus 4 is 1. And because I've picked my x-coordinates so that they're the same distance from the vertex on each side, I know that the y-coordinates are going to be the same also. If you didn't remember that, you could have just continued plugging things in and you would have gotten the same y values though. So all that's left to do now is to plot. So let's see, we have negative 4, 4. Negative 3, 1, negative 2, 0, negative 1, 1, and then 0, 4. So our parabola would look like this. And that's it. Maddie, you happy there?
Yeah, thank you.
Of course. And then we want to look at number 4 from homework 7. So just slide back over to homework 7. Looking at number 4. Okay. I notice that this is a vertex form equation. So to solve a vertex form equation, I'm going to use the reverse order of operations. So I'll start by subtracting 7 from both sides. And then dividing both sides by 8. And then to get rid of the squared, we'll square root both sides. So when we square root both sides of an equation, it creates a plus or minus. And then we just add the 3 over. And then we have some simplifying we need to handle on this piece, right? So the negative sign underneath the square root, I can drop the negative sign under there and put an I out front. And then because it's a fraction, I can think about it as the square root of the numerator over the square root of the denominator. And I can simplify the square root of 8. I recognize that 8 is 2 times 4. So the square root of 8 is the square root of 4 times the square root of 2. So that's just going to become 2 root 2. And we remember we don't like to leave a radical, square root in the denominator of our fraction. So to get that out of there, I'm just going to multiply the top and bottom by the square root of 2. So I'm going to end up with x equals 3 plus or minus. Square root of 5 times the square root of 2 is the square root of 10. The square root of 2 times the square root of 2 is the square root of 4, which just simplifies into 2. And then I still have this times 2 there. So it's 4. And I'll just stick the I there at the end. So this would be like the best version of my answer. Although even on the test or quiz or whatever, I would accept this without the radicals being simplified and all of that. Although if you did try to simplify the radicals, I would expect that that part is done correctly. But if you had stopped at that point on a test or quiz, I would be okay with that still. We haven't really talked about how to simplify radicals in great detail. We'll do that later in second semester. And at that point, going forward, I expect that all that kind of thing is taken care of. But here, while it's a skill that I think that we've seen a little bit before, I just don't know that it's a fair expectation to have that you're doing all of that simplification all the time. I'm going to do it when we do the examples, because if you take a standardized test and it's like a multiple choice test, the answer in green would not be one of the choices. My answer in red would likely be the choice. So I just want to make sure that you're at least seeing that so that you're not confused if you run into those sort of situations. Okay. Anybody else from the homework?
Mr. Kulik, I have one.
Okay, go ahead, Natalie.
It is number 3 on homework 7.
Okay. So this one here. So I noticed that this is a standard form problem. So since the leading coefficient is 1, I could try to factor this. But I'm going to notice really quickly that there aren't two numbers that multiply to give me -1 that add to give me -2. So I'm not going to be able to factor this, so I'm going to be stuck using the quadratic formula. Not stuck, but that's really my only option at this point. So -b plus or minus b squared minus 4ac all over 2 times a. So what do we get? Negative of -2 is +2. 2 squared is 4. And then 4 times 1 times -1 is -4. 4 minus a -4 is 8. And the square root of 8 we can simplify just like we did before. So that's 2 root 2. And then you could think, right, since they both have the common denominator, 2 over 2 just is 1. And 2 root 2 over 2, the 2's here can kind of cancel out. And we're left with just 1 plus or minus root 2. Again, if you had stopped here on a test or whatever, I would still mark that as full marks, or give that still full marks. But if you elected to try to do any kind of simplification, I'd expect the simplification you do is correct if you continued to go forward. So if you made mistakes going forward, I would deduct points there. But if you got to that point and then as long as you did correct stuff afterwards, it didn't really matter. It wouldn't matter to me how much further you went. Is that okay?
Thank you.
Of course. Okay. So let's start with the new stuff today. So today we're going to start talking about modeling quadratic functions. So the idea here is I want to take some information about the graph and use that to create the equation for the quadratic function. So when I say info, what we're talking about is either points and or key features. So this really just boils down to like 3 different situations. The first situation, you're given the vertex and then one other point. The second situation, you're given 2 x-intercepts and one other point. And in the third situation, you're given 3 points, where we don't know anything specific about those 3 points. In the first situation, we're going to use a vertex form equation. In the second situation, we're going to use an intercept form equation. And in the third situation, we're going to use a standard form equation. Okay. So let's go ahead and do some examples. So in this first example, we're given a vertex and some other point. So this is situation 1. So we need to be using the vertex form equation. So for us to have a quadratic function, what we really need to do is figure out the values for a, for h, and for k. That's what we're looking for. Now, the nice part about a vertex form equation is that the vertex is h comma k. So right away I can say that h is -2 and k is -5. Almost instantly. 2/3 of the way we're done, right? We got h and we got k, really without having to do any work at all. That's lovely. We still are left to find a. So the piece that we haven't used yet, so we're going to use this to find a. And the way we're going to do that is this point is an x and a y, right? So I can plug in my values for h and k, as well as x and y, into my vertex form. So I'm going to plug 3 in for y. A is what we're searching for still. -2 in for h. And -5 in for k. And now I can just solve for a. So -4 minus a -2 is -2. And -2 squared is 4. So that really becomes 4a minus 5 equals 3. And now I can just solve for a. So add 5 to both sides and divide both sides by 4. And I get a equals 2. Now I have my h and k, so I can combine those together into my vertex form equation, and there's my final answer. Any questions on that? Hopefully that feels pretty straightforward, right? Very similar to things we did when we modeled absolute value functions, right? It's almost the same process there. Oops. Let's make that there. Okay. So in this problem, we're given that our quadratic function needs to pass through the 3 points -2, 0, -4, 0, and 1, 10. But these points are not just any old points, because their y-coordinate is 0. We have our x-intercepts. That means that this is situation intercept form. So x minus p times x minus q. And if we remember from intercept form, when we found x-intercepts in intercept form, the intercepts are just our values for p and q. So again, we're already 2/3 of the way there, right from jump. All that we're left still to find is a. How are we going to find a? We're going to use that third point as an x and a y. So we'll plug in our values for x and y and p and q and solve for a. So y was 10, x was 1, p is -2, and q is -4. Oops. So 1 plus 2 is 3, 1 plus 4 is 5, 3 times 5 is 15. So I have 10 is equal to 15a. If I divide by both sides by 15, I get that a is equal to 10/15, or reduces down to really 2/3. So if I take a, I can plug those in to get my answer. So just as to clarify or to point out here, in each of these problems, our final answer should be an equation that has both x and y in it. So occasionally I see students still plugging values into x and y and writing this with no variables. A quadratic function needs to have two variables and needs to have an x and a y in it. So please make sure when you write your final answer, you have x's and y's still in your answer. The next one, oops. One moment, please. Is that doing it? Okay, that is doing it. Maybe. Okay. Sorry. I had wrote myself out some notes earlier, and I wanted to pull those up because these problems are ones that you just can't like pick any old numbers and have it work, you need to have stuff kind of planned. Well, I mean, you can pick any old number. You wouldn't like the answer you're getting at the end. Okay. So let's say that the quadratic we're looking for passes through these 3 points. So we can take a quick look and we notice that none of the y coordinates are 0. So we know right away that none of these are x-intercepts. So these are just like 3 random points. So that tells me that we're in situation 3. So we need to be using a standard form equation. So for our answer, what we need is we need a value for A, a value for B, and a value for C. But remember, the values for A, B, and C don't really correspond in any way to the points on the graph. So these points that we're given are not directly related to A, B, and C in any kind of shortcut way like we were able to do before, where like, oh, the vertex gives me the H and K, and oh, the x-intercepts give me the P and the Q. Nothing that you're given is going to give you the A, B, or C. So what we're going to do, we really have 3 variables to solve for, A, B, and C, and they're all in the same equation. So what we're going to do is we're going to create a system of 3 equations that each contain A, B, and C, and then solve that system similar to what we did in the last chapter. So how am I going to make those 3 equations? Well, I have 3 sets of x's and y's. I'm just going to take each one of those pairs and plug it in for x and y into my standard form equation. So the first time I'm going to plug 8 in for y and -1 in for x. Then I'm going to plug 5 in for y and 2 in for x. And then lastly, I'll plug 16 in for y and 3 in for x. And what I have now is a 3-variable system. So this is something that we learned how to solve in the previous chapter. So I'm going to do a little bit of cleaning up on this to format it in a way that looks a little bit familiar, or more familiar. So I have all these squareds, so I'm going to simplify those parts. And then our equal sign is on the left-hand side. Usually we write the equal sign on the right-hand side, so I'm going to flip that also. So -1 squared is just -1. And -1 times b is just -1b. I have 1c is equal to 8. And 2 squared is 4. And 3 squared is 9. And that's my system. So again, it's the same thing that I had before. I just cleaned it up a little bit. So I did some simplifying and I reformatted it so the equal sign was kind of in the familiar location. And what's the fastest way we have to solve a system like this? Think back to last chapter. What was the fastest, easiest way we had to solve a system? Would anybody have an idea? Feel free to chime in if you do. So some of the ways that we had to solve systems were substitution, elimination. We talked about graphing. We talked about using a matrix equation, Cramer's rule, Gaussian elimination. I think those were all the different solving methods we talked about in the previous chapter. right? Which one of those seemed like the fastest and easiest one? Well, come on, guys, it's Gaussian elimination, right? That was the best one because you could do it all on your calculator and you didn't have to really write anything down, right? The calculator did all the heavy lifting for us. So just as a reminder, what we did is we started by translating this system into a matrix. So the dimension of this matrix is going to be 3 rows because I have 1, 2, 3 equations. And the matrix is going to have 4 columns, 1 column for the A's, 1 for the B's, 1 for the C's, and 1 for the answers at the end. And my matrix I'm just going to create by pulling the coefficients from this system. So I'm just taking the coefficients to create this matrix. Any questions on what I did there? Okay. Once I have that matrix, I'm going to use the RREF command on it. And when I do that, the calculator is going to output me the following matrix. Which again, remember, we can interpret each row as a solution. So this says 1a plus a bunch of zeros is equal to 3. So just a is equal to 3. We have 0 plus 1b plus 0c is equal to -4. So b is -4. And 0a, 0b plus 1c is equal to 1. So just c is equal to 1. So there's our final answer. Just as a refresher, I'm going to pull my calculator out and kind of go through how we do the Gaussian elimination on the calculator again, just to refresh your memories, because it's been, a little while since we did this. But it's a super useful method. It's not the last time we'll have to solve a system in this class, so it's a good thing to kind of hang on to. So if you have your calculator handy and you want to follow along, you're welcome to do that. If you just want to sit and watch, that's cool too. Or if you're like, yeah, I'll just look at the video again later once you've gone or once you've posted it, that's okay as well. So the first thing we're going to do is we're going to enter this matrix into our calculator. So to do that, we'll observe that above the x to the -1 button in blue is the word matrix. So to access the matrix menu, I'm going to press second and the x to the -1 button. The matrix menu has 3 tabs. It has a names tab, a math tab, and an edit tab. To type a matrix in, we're going to go to the edit tab. You might be observing that I have a bunch of numbers here. You might not. If yours are blank, that's no big deal. If you have numbers here, that's no big deal. We're just going to use matrix A and type over whatever we had there. So we'll start by entering the dimension of our matrix. It's always going to be a 3x4 for this chapter. So I can 3x4. And then I'm going to just type in the coefficients, or type in the numbers in my matrix exactly as they look on my paper. So 1, and then enter, -1, enter, +1, enter, etc. So I've just gone ahead and typed in the numbers from my paper into my matrix in the exact same locations. Once I've done that, I'm going to exit out to the main screen. So I'm going to press second and the mode button. That'll exit me back to the main screen. And now I'm going to retrieve the RREF command. So I'm going to go back to the matrix menu by pressing second, and then the X to the -1 button. This time I'm going to go over to the Math tab, so I'll press the arrow button to move over to the Math tab, and I'm going to scroll down till I find the RREF command, and making sure that I pick the RREF command and not the REF command. You should have two R's. Once I find RREF, I'll press enter to select that command and paste it to the home screen. And now I need to go back and retrieve this matrix A that we just made. So I'll go back to the matrix menu by pressing second and the X to the -1 button. This time I'm going to be in the Names tab. From the Names tab, I'm going to select matrix A. That's the one that we just filled in a second ago. Close the parentheses and press enter. And there's my output, which we talked about how to interpret. Any questions on that? Good. That should have been relatively easy for us because this is all a skill that we just got done doing and we should hopefully still be relatively comfortable doing. That's the last topic that I needed to talk about today. So we have two things that I need you to work on. So I have homework 9 that I've posted into the OneNote. So this is just 6 problems similar to the things that we did in the example. So that shouldn't be a big deal. And then I also, today we're going to take our homework quiz for this chapter. The homework quiz for this chapter is going to be done a little bit differently. So if we go to our PowerSchool page, I'll show you how I have that set up. And you're free to follow along right now if you'd like. If you want to go to PowerSchool and meet me there at our PowerSchool page, I'll show you what we're going to be, or what you're going to be doing. So we'll go to the Honors Algebra 3-4 page. And you'll notice at the top of our bulletin board page is something, or a content block titled Factoring Homework Quiz. So this homework quiz is all on factoring. So it is timed. You have 10 minutes to complete this once you've started it. It is a fill-in-the-blank quiz. So the way this will work is I'm going to give you a quadratic and ask for the factored form. And then you're going to type your answer into the blank. Now, if you've done these fill-in-the-blank quizzes on PowerSchool before, you know that it can be kind of picky about how you're formatting your answer. So I want to be real clear about what your answer needs to look like in order for the program to accept it. So to get full credit, you need to format your answer the following way. So you should have no spaces in your answer. So for example, x plus 2 times x plus 3, that's a good answer. But x minus 2 times x plus 3, where there's a space, that's going to get marked wrong. There should be no spaces anywhere in your answer. The second thing, we need to make sure you're using a subtraction symbol and not writing it as like plus a negative. So again, for example, x minus 2 times x plus 3, that'll be marked correct. But if you had typed x plus a negative 2, the PowerSchool won't recognize that as the correct answer. So please make sure you're using subtraction and not writing it as plus a negative number. The order in which you write your two parentheses doesn't matter. So for example, x plus 2 times x plus 3 and x plus 3 times x plus 2 would both be acceptable. So the order that you write them doesn't matter. If you run into a problem that's not factorable, you need to write the letters NF. And it doesn't matter if they're capital or lowercase, but those are the only two letters you should write. And then the way I have this set up is that you get 2 chances for each problem. Although if it takes you 2 tries, you only get half credit for that problem. And this homework quiz is open until 12:35, so the end of our scheduled class period. Does anybody have any questions on that? Oh, well, hold on, one more thing. These directions will be on the homework quiz when you click on it, so you'll see all these directions again, so that you don't have to remember them or write them down or whatever. They'll also be, once you've started the homework quiz, they'll be visible at the top of the screen for you also, so those will all be there. And it's timed for 10 minutes. I think I said that at the beginning, and there's 10 problems, so it's fairly generous on the time, right? The format's a little weird, so I figured a little more time is probably reasonable. Okay. Anybody with a question about the factoring homework quiz? Good. So this needs to be done today. The quiz will be open until 12:35, so I would say as soon as I dismiss you from the Zoom call, you should go in and try to do that, and get it done so you don't forget about it or whatever. And as long as there's no other questions, I'm going to dismiss you guys from class. So just remember, before you log off the Zoom call, you should type bye into the chat. And don't forget to do the homework quiz, and have a great Thanksgiving and a good break. And we'll see you back in, a week. Or, 10 days really with the weekends or whatever, but you know what I mean. Have a good day.
Thanks, Mr. Pruitt.
You're welcome.
Thank you.
You're welcome.